Hello everyone, welcome to our TESOL Global YouTube channel. This is our FPGA video series where we will explain different aspects of FPGA. We will provide different examples and demonstrate some projects. In today's video, we will give a brief introduction to FPGA and its meaning. We'll also go through the basic architecture of an FPGA. FPGA stands for Field Programmable Gate Array. We'll try to explain what does Field Programmable Gate Array even mean. To start with, FPGAs is basically a configurable chip or integrated circuit or IC. It mainly includes logic blocks and interconnects. Surprisingly, both of these modules are user programmable. Now, the part field programmable represents a device that can be programmed in the field, or the functions of the device can be modified on site. Also, it can be programmed repeatedly or any amount of time. For example, let's consider an FPGA is installed in a laboratory. Some of the lab users need it to be used as an addition unit, but another group of users requires it to be an mux. So the users can use same FPGA and program it for any of these two applications whenever they require very easily. Now, gate array represents unit of logic gates or blocks that are organized in a matrix form out of the box in an FPGA. Those logic gates or blocks are connected with programmable interconnects. So here you can see an example of FPGA chip which has programmable or configurable logic blocks organized in a matrix form. These blocks are also called CLBs. All these CLBs are connected through programmable interconnects, and there are also programmable IOs which can be programmed or changed as per user requirement. Next, we have a basic building block or one unit of a CLB. It includes a lookup table or LUT. Most of the LUTs have 4 or 6 inputs and a single output. You maybe find older FPGAs with 3 inputs. CLBs also have a flip-flop and a multiplexer or mask. Now moving on to the details of the units present in the CLBs. LUT, which stands for lookup table, in general terms is basically a table that determines what the output is for any given input. In the context of combinational logic, it is the truth table. This truth table effectively defines how your combinational logic behaves. The way FPGAs typically implement combinational logic is with LUTs. And when the FPGA gets configured using programming language such as Verilog or VHDL, it just fills in the table output values, which are called the LUT mask, and is physically composed of SRAM bits. We'll try to cover how SRAM works in an FPGA in another video. Let us know in the comments section if you are interested to learn more about SRAMs. So, an LUT carries a customized truth table for every possible input. The results are already stored, which gets loaded as the FPGA is powered up. It simply generates output based on the input combinations given by a user. Next, flip-flops are binary shift registers used to synchronize logic and save logic states between clock cycles within an FPGA circuit. On every clock edge, a flip-flop latches the 1 or 0 value on its input and holds that value constant until the next clock edge. So next, the multiplexer or mux are used all the times in FPGAs in various sizes and configurations. LUTs have their own mask. The mask example showed here in CLB is mainly to transfer the processed logic results from LUTs to the output. So this is the end of this video. In our next video, we'll explain what are the FPGAs available, applications of FPGA, what coding languages are used for FPGA. We'll mainly use Altera or Intel FPGA for this video series. So we'll show what softwares are needed for that and one example code. Please subscribe to our channel for more videos like this. Would like to thank those who already subscribed and helping us to grow our channel. Add likes and comments and give us suggestions of what kind of video you want us to make. Follow us on LinkedIn, Twitter or X and in Facebook. Thank you for watching. See you next time.